Hello everyone, I welcome you all to the new chapter Quadrilaterals. Myself Palak Agrawal and I'll be teaching you this chapter thoroughly. So let's start and see what we have for today. Okay, so what's quadrilateral? What's the definition of quadrilateral? When four points are marked on a plane and if all the points are collinear, that is in the same line, we obtain a line segment. But if they are non-collinear, okay, if they are not in a same line, then what we get, if 3 points are collinear, then we get a triangle. Okay, this two can be met and 3 and 1. But if none of the point is collinear, then what we get is quadrilateral. Just see in the figure there. Okay, so all 4 points are not collinear, no pair is collinear, so that we can obtain a quadrilateral. In any fashion, the lengths, breadths are not defined in quadrilateral. So quadrilateral is simply ABCD of four sides AB, BC, CD and DA and four angles, also the four vertices and two diagonals. Correct? So this is the quadrilateral with its distinctions and properties. The sum of quadrilateral angles is 360 degree. Okay. Triangle sum we have learned 180 degree and quadrilateral is just double. Okay. So it's 360 degree. And you have already been known that it has two diagonals. Now, what are the different types of quadrilateral? We have to learn that first. So, see in the figure, you can see each being a different shape and different size. So, first can be known as trapezium, second can be called as rhombus, third also rhombus, fourth rectangle, fifth square, and sixth one is kite. So they all have a different properties. I mean by saying that quadrilateral has no such property defined rather than being the 4 points non-collinear, but the types have specific properties and specifications in them. Parallelogram is just a major distinction of square and rectangle. Okay, all both the sides are parallel to each other. Again, this is a parallelogram. I have just redefined parallelogram as rhombus, quadrilateral, rectangle and square. Okay. Now, last one is kite. I have already told you, but they are now you can see the further distinction of parallelogram, rectangle, rectangle. It could be square too, and kite, rhombus, rhombus. Correct. Now, you would say, ma'am, you would say that it's square, but it's showing rectangle and showing rhombus because a square has the property of rectangle and also a property of rhombus. Okay, so they are distinguishing between the two figures based on the properties. Now you have seen it's written square, correct? So it's a square too. Now, last one is kite. I have already told you. In the kite, the longer sides are equal to one another and shorter sides are also equal to one another. So, square, rectangle, and rhombus are all parallelograms. A square is a rectangle and also a rhombus. A parallelogram is a trapezium. A kite is not a parallelogram because none of the two sides are parallel. Trapezium is not a parallelogram because only one pair is parallel and the other pair intersects. Rectangle and rhombus is not a square, but square is also a rectangle and rhombus. So, with that, we have covered the different types of quadrilaterals. Now, we want to move forward towards the properties of a parallelogram. We have learned about three parallelogram. Which one are they? Rectangle, square, and rhombus. So, what are its properties? The properties one states that diagonal of a parallelogram divides it into two concurrent angles. We have already learned congruency condition. What it means? It means that they overlap completely. Correct. So if AC is a diagonal of parallelogram ABCD, then we can state that ACB and ACD, both the triangles are congruent to one another. Correct. Now, in a parallelogram, opposite sides are equal. Okay, so AB would be equal to CD and AD would be equal to BC. Correct. And they are parallel obviously. Now, third property states that each pair of opposite sides of a quadrilateral is equal, then it is parallelogram. Just opposite. A quadrilateral assuming to be equal sides of the opposite pairs, then it is called as parallelogram. Correct? And diagonal is drawn just to clarify. In a parallelogram, opposite angles are also equal. Okay. So, what does opposite angles mean? I hope you know that. I have already covered types of angle. Now, if in a quadrilateral each pair of opposite angle is equal, then it is a parallelogram. So 8.5 is a converse of 8.4. Correct? Okay. 8.6. Diagonals of a parallelogram bisect each other. Bisect each other in the sense OA is equal to OC and OB is equal to OD. Okay. So they intersect at a midpoint and dividing the diagonals into 4 equal parts. If a diagonal of a quadrilateral bisect each other, then it is a parallelogram. So 8.7 is again a converse of 8.6. Correct? Now, first example, show that each angle of a rectangle is 90 degrees. Now, just pause me for a while and think how you would show. You have already learned 6-7 properties of a parallelogram. Just try to use one. So, in order to solve this question, I would like to start with firstly drawing a smaller figure. Just a quick version of that. Okay, just see. I am taking this line and this line. Okay. So what it is? This is supposedly D and C. Okay, so I'm just taking line, not line segment CD, which is given to you question. So it's the same thing. I'm just extending it out. Okay, nothing else. Correct. So these are the points. Now we can consider this as a transversal, which is AD, and I'm just naming it out angle 1, angle 2, angle 3, and angle 4. Okay, so we know that by the property that interior angle sum is supplementary, correct? So angle 1 plus angle 2 would be equal to 180 degree. Since AB is parallel to CD, which is the property of rectangle, we can state that angle 1 plus angle 2 is 180 degree. So now we can also state that with considering this as a traversal, angle 3, angle 4 is also 180 degree. Also angle, now just consider this two parallel and this as a traversal. Okay, so angle 1 and angle 3 would also be 180 degree. And angle 2, angle 4 would also be 180 degree. Correct? So just try to solve it out and you would come to a conclusion that angle 1 equal to angle 3, angle 4 equal to 90 degree. Okay, I hope this is clear to you. And this way we can prove that each angle of a rectangle is 90 degree or right triangle. Now, show that diagonal of a rhombus are perpendicular to each other. Perpendicular to each other in a way like this we have to show. Okay, so how we would do that? Just pause me out, try it out first on your own and then check out. I hope you have tried and it's a really easy question. Okay, now see what I am going to do here. I'll just write in triangle A, O and B. Okay, and triangle. Okay, I am writing AOB, so I'll write here COB. Now, while I'll write COB, I'll just show you. Okay, what are the properties of a rhombus? For sure, correct. Also, the property that these two are equal, so this is also equal. We know that diagonals intersect each other at midpoint, correct. So we can write OA is equal to OC by the property OB is common and AB is equal to BC since it's a rhombus, so obvious. So by CPT, by triple S, triangles are congruent, correct? Now by CPCD, angle AOB would be equal to angle COB, correct? So this angle 1 and angle 2. Correct. Now also know that by linear pair axiom angle 1 and angle 2 is 180 degree. So we can state that angle 1 is equal to 90 degree equal to angle 2. And angle 1's opposite would be angle 3. So angle 3 would be equal and angle 2 would be equal to angle 4. Now all are 90 degree and hence prove that rhombus diagonals are perpendicular to each other. Correct. I hope you have got the solution. Next question. ABC is an isosceles triangle in which that AB equal to AC and AD bisect exterior angle PAC. Correct? So, show that CD is parallel to AB. Okay, it's given. Correct? Now, we have to show that angle DAC is equal to angle BCA. Now, we are given that CD is parallel to AB. So this angle and this angle we need to show that they are equal in first case. Correct? And I'll just name it out 3 and this as 4. Since these lines are parallel, so we know that angle 3 would be equal to angle 4. Okay? Since by AB parallel to CD. Correct? I hope you got my point. Correct. Okay. Now, just see this triangle. This angle may be 5. Angle 2 would be angle 5 by angles opposite to equal sides of triangle. Correct? So, they are also equal. Now, I hope you remember the exterior angle property which states that exterior angle sum. Okay, I'll just name it 6. The exterior angle is equal to, sum is equal to opposite interior angle. Okay, 5 plus angle 2. And we know that 5 and 2 both are equal. Correct. And angle 1 is equal to angle 6. And angle 5 is equal to angle 2. So we can state that 2 angle 1 and we need to prove for 2, right? So we will write 2 angle 2. 2 and 2 cancel, angle 1 is equal to angle 2. Hence, angle DAC equal to angle BAC. So, and if they are equal, that means that AD is parallel to BC. Okay, by interior opposite angle. And AB is parallel to BC. Correct? So, if opposite sides are parallel, that means that ABCD is a parallelogram. Hence, proved. I hope you got the question. Now we'll stop it today from here, and from next part we would be continuing with the question and also know how to solve it. Okay. Thank you so much for attending my lecture.